In your previous activity, you did a few things working with the fundamental counting principle. Maybe you made a tree diagram to help you. I'm going to discuss how to make a tree diagram. Examples with a tree diagram here. A pizza shop offers a special price on a 2-topping pizza. You can choose one topping from each of the following groups: provolone cheese or mozzarella cheese. And then you can choose pepperoni, sausage, or hamburger. It says begin a tree diagram with the two choices from each cheese choice, extend the line for each meat choice. How many different combinations of 2-topping pizzas are possible? Well, we have a provolone. I'm going to use that P stand for provolone, or a mozzarella cheese. If we chose provolone, we could also choose pepperoni. There's one combination, provolone and pepperoni. Second combination would be provolone and sausage. A third would be provolone and hamburger. If we chose mozzarella, well, we could choose mozzarella and pepperoni. There's a fourth combination, mozzarella and sausage, mozzarella and hamburger. So at the bottom here, we have 6 possible choices. Now, if I were to ask you, what if there was a third choice in which maybe we got to choose onions or green peppers? Well, if there's a third choice here, well, we could extend it. If I chose provolone, pepperoni, I could choose onions or green peppers. Same thing with the sausage. We could go one of 2 routes, onions or green peppers. Onions or green peppers. And now we're up to 6 choices total. We're going to do the same thing here, onions or green peppers, onions or green peppers, onions or green peppers, and we have a total of 12 combinations if we had chosen from one of those 3 options. Now let's think about this. There are 2 options here, there are 3 options here, and there are 2 options for our third choice. This is the fundamental counting principle. What's 2 times 3 times 2? This would be 6 times 2, which is 12. And that is how many combinations we have in the end. This is our fundamental counting principle. So this is something to keep in mind, something to write down. Our fundamental counting principle says that if there are m ways to do one thing and n ways to do another, then there are m times n ways of doing both. In other words, use multiplication to find the total number of outcomes. So let's take a look at a couple of examples. In the red, it says, if you want to hit one note on a piano with 88 keys and play one string on a banjo with 5 strings, then how many ways are there to do both? Now, I don't want to name all 88 keys. So, if I want to hit a note with 88 keys, I have 88 ways to do that. There are 5 ways to play one string on a banjo. So to do both, there are 88 times 5 ways, which would be 440 ways. Let's look at a second example here. If you want to draw 2 cards from a standard deck of 52 cards without putting them back in the deck after you pick the first one, how many ways can you draw the 2 cards? So if I draw the first card, I've got 52 cards in the deck. Key thing, without putting that card back, how many cards are still left in the deck? To draw my second card, well, there are 51. So 52 times 51 would leave us with 2,652 different ways of drawing 2 cards. Kind of a lot. Let's go to another example, a little more complex. I'm choosing a secret password with letters, 26 possible letters from A to Z, and digits, 10 possible digits from 0 to 9. In my password, I don't want to use the digit 0 or the letter O because they look too similar. If each digit or letter can be used more than once, so I can repeat, how many passwords are possible with 2 letters followed by 4 digits? Well, if I'm taking out the O, that leaves me with, instead of 26, I have 25 letters. So my first, I can choose from 25 letters. Now, if I can repeat it, it means I can use the same letter twice. So for my second letter, I've got 25 options. Now, there are 10 possible digits from 0 to 9, but we're not going to use the digit 0. So that means I have 9 numbers to choose from for the first number. And if I can repeat, I can use the same number. I'm going to have 9 possible choices for all of them. So to figure out the combination of words, I need to multiply each of these. I need to multiply 25 times 25 times 9 times 9 times 9 times 9. And I get 4,100,625 different passwords. Quite the combination of passwords to choose from. Be hard to hack into that password. Last idea here for this lesson is talking about a factorial. Now, a factorial may be used to find the total number of outcomes of a scenario with descending amounts of choices. The factorial of n is written as n with a little exclamation mark. We call that a factorial. It's calculated by doing n times n minus 1 times n minus 2, and so forth. So for an example, 4 factorial here means I take 4 times 3 times 2 times 1. Each number goes in descending order that we multiply, and so 4 factorial is equal to 24. So different ways we do this is, how many ways can 7 people stand in a line? This is where order is important. Order matters. So if we're trying to put people in order in a line, there are 7 people that can be first in line. Once we choose that one person, then the second person in line, there are 6 choices to choose from. The third person, there are 5 choices. 4 choices, 3, 2, and 1 for the 7th person in line. So if we take our calculator, we do 7 times 6 times 5 times 4 times 3 times 2 times 1, we get 5,040. Let's say a coin is tossed 5 times. How many arrangements of heads and tails are possible? This one is not going to be factorial. Not going to be factorial. We have 2 arrangements of head and tails on the first one try. We have 2 arrangements on the second try. And hopefully you see where this is going, which is the same thing as 2 to the 5th power. And so 2 times 2 times 2 times 2 times 2 is, well, we got 2 times 2 is, I'm sorry, I lost track. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 would give us 64. Last one, this is going to give us kind of a big number. 9 students have to give a presentation. 1 student insists on going first. If the student's wish is granted, how many ways can the teacher arrange the presentations? Well, there are 9 students that can go first. But we have 1 that wants to go first. So if we already choose that person and let him go first, well, that 1 person is going first. Then we've got 8 people that don't care and they could go second. And then we have 7, 6, 5, 4, 3, 2, and 1. So we've got 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 equals 87,360 different ways we could arrange the presentations.